Today we're going to do systems of inequalities. All right. Systems of inequalities basically takes your linear inequalities from chapter 5 and it adds a line to it. That's it. All right. All your same rules apply with your negative signs as far as that goes. All of your graphing goes the same way with dashed lines and solid lines. That's all still true. Except we have 2 lines this time. That's the only difference. All right. So first slide, system of inequalities. It is a set of 2 or more inequalities with the same variables, just the same way like a system is, 2 equations with the same variables. All right. You won't go more than 2 until you come back to me in Algebra 2. Okay. When we come back in Algebra 2 is when we'll go more than 2 in a system. Okay. The solution of a system, make sure you highlight this or something. The solution of a system of inequalities with 2 variables is the set of ordered pairs that satisfy all the inequalities in the system. Okay, now, on the board here, I have this little made up one, and I'm going to make it up. Let's make it y is less than or equal to 2x plus 4, something like that. And this part down here is shaded. Why is that shaded? Mr. Watson.
In the shaded areas, and it could be part of the solution.
It's part of the solution, which makes the original inequality what? I'm looking for a T word.
True.
True. It makes the original inequality true. All right. Now, for a system, turns out you have to be true for not just one, but for both. You can't be true for just one. You have to be true for both now. That's the difference. Okay? That's the difference. Therefore, the solution set is represented by the overlap, or the fancy word intersection, of the graphs of the inequalities. Okay? So that's what we're looking at today. We're looking for where we're going to graph 2 of those that are on the chalkboard. We're going to see where they overlap, and that overlapping section is going to be what we shade now. Okay? Everybody good? Okay, let's try it. Okay, so we have the equations. Y is greater than negative 2x plus 1. Y is less than or equal to x plus 3. All right, now your process for the graphing itself doesn't change. Okay, it's not going to change basically ever. Your process of how I taught you to do these, we're going to switch up just a little bit for cleanliness. All right. So the first equation is y is greater than negative 2x plus 1. Let's graph it first. Okay, where do we start? Minor? 1. 1 on the... Which one? Axis. Dylan? The y-axis. Good. And we're going to move down 2 and to the right 1. Down 2 and to the right 1 according to our slope. Up 2, left 1 also. What type of line? Okay. All lines are straight and linear. Dotted. There we go. Dotted line. Okay. And then what would we do in chapter 5? Chapter 5, we would do this, we would shade, and we'd be done. We would get a, what? Remember that's called? We would test a... Variable? Nah, not variable. We would test starts with a P. A point. And as long as the line didn't go through this specific point, I said to always test what? Always use 0, 0. Okay, so do that now. We're going to test 0, 0 in the first inequality. So I'm going to go, whoops. Oh, wrong way. Redo. There we go. I'm going to go up here. So plug in 0 for y and 0 for x. So 0 is greater than 1. True or false?
False.
False. Okay, and since it's false, you would always do what? shade away. You would shade away. But don't go full-blown shading yet. Here's what I want you to change now. Okay? I want you to draw just like itty-bitty arrows. Okay? From your black line the way that you intend to shade. All right? You don't have to do a bunch. Once we do one, you'll kind of see what you need to get accomplished. Okay? But just draw itty-bitty arrows so you know which way to shade. Okay? Second one I'm going to do in red. All right? So that one we're going to start where?
A 3.
3? And how does that guy move? Up 1, right 1. All right, up 1, right 1. Could also move how?
Down 1, left 1.
Down 1, left 1. Good. What type of line? Solid. Doesn't go through 0, 0, so go ahead and test 0, 0. Do that down here. So you get 0 is less than or equal to 3. True or false? That one's true. So your red line, you're going to shade what compared to the origin? Towards it. Okay, now watch how many arrows I draw this time. Oops, wrong side. Okay, I only drew 2. Because what's the solution? Go back to that page. What's the solution of this inequality system? Go back a page. Stuff I told you to highlight.
Oh, the solution of which this is we call it two variables is the set of other pairs saying
Where they?
satisfy all of the inequalities.
Which is going to be the next lines.
The solution
The overlap. Thank you, Clayton. The overlap. Okay? Now, remember what these little arrows represent. They are the way you intended to shade. Okay? So, from the black line, we intended to shade to the right, basically. Okay? We intended to shade over here. Whoops, there we go. We intended to shade over here. From the red line, we intended to shade over here. Visualize it. Which section would have the overlap of shading? 1, 2, 3, or 4? 2. Okay? Or the way the arrows point towards each other. Okay? That's the section, and that's the only section that I want to see shaded. Okay? Is this section right here.